Hello and welcome to Wireless Visionaries. In this video, we will talk about phased arrays. So arrays just means that this array just means that multiple antennas, they are arranged in some configuration that act together to produce a desired pattern like this. And then in phased array, we can electronically steer the pattern without having to move the array. And this is done by adjusting the phase of the antenna elements. Like this, we are steering the beam towards specific direction. And phased array can also be used to generate multiple beams from phased array that can steer the beam independently from each other. So that means we can form multiple beams from the phased arrays. So next, we need to know how we can form a more directive beam from the array and how we can steer the beam through phase shifters. So let us take an isotropic antenna that is radiating a sine wave and is radiating equally in all directions. So this is the radiating pattern for the isotropic antenna, and obviously it has no directivity and it is radiating equally in all the directions. Now if we take two isotropic antennas radiating out the exactly same sine waves, and these two antennas are placed lambda by 2 apart, and this is the radiation pattern that we obtain. So we can see in the bore side direction, two signals are perfectly in phase with each other. That means both are high or low at the same time, and they constructively add in this direction. Whereas in the horizontal direction, the two waves are exactly out of phase with each other and they cancel out, and a very little energy is there in this direction. So this we have seen the radiation pattern when the two isotropic antennas that are placed lambda by 2 apart creates. Now what if we put more antennas? What if we put more antennas that are spaced lambda by 2 apart? What we will get? We will get a narrower beam, we will get a high directivity, we will get a weaker side lobes where the gain is much lower than the main lobe. So for example, here we have 3 antennas, 4 antennas, 5 antennas and 8 antennas. So as we are increasing the number of antennas, we get 3 benefits. First one is we get a very narrower beam. Second one is we get a very high center directive beam, and third we get a weaker side lobes. So now what we have done, we align the isotropic antenna in the linear array, and the interference between them results in a directive center beam. So this is the basic principle behind how an array of antenna can create a directive beam. So basically a pattern is created from the constructive and destructive interference between the antenna elements, and each time we add an antenna into the array, a 3 dB improvement we get in the power gain. So next, what if the user is not present in this direction, that is the bore side direction, and what if the user is present in the horizontal direction? In the horizontal direction we have obviously no energy, whereas the most of the energy is directive towards the bore side direction. So for that we need to understand the beam steering, how the beam is steered to the 90 degree towards the horizontal direction. So this was the radiation pattern which we obtained when two isotropic antennas are placed lambda by 2 apart and radiates the same signal. Now suppose if one of the antennas is phase shifted by half lambda with respect to the other. So that means this antenna is phase shifted by lambda by 2 with respect to the first antenna. Now the two antennas are sending the same signal that are completely out of phase. So when the signals are completely out of phase, so in the bore side direction, we got zero signal, no signal, and the most of the signal is present in this direction, in the horizontal direction. So the waves are radiating in this form. And there is almost a little or no signal in the bore side direction. So by phase shifting the signal by lambda by 2, we rotated the main beam that was previously towards the bore side direction by 90 degree. And similarly, by delaying the signal and changing the phase shift of the signal, we can steer the beam to a particular direction with appropriate phase shifts. This is how phase shifts steer the beam pattern. Now, if we have 8 antenna elements, and here in this figure, we have 8 antenna elements, and each element is phase shifted compared to the element that is next to it. And we obtain a total of 7 phase shifts between the first and the last element. So we can see that it can steer the beam towards the specific direction. So that means anywhere the user is present, it has the ability to make a directive beam towards the direction of the user. So what do we understand? First, the array creates a pattern that is a more directive beam towards the bore side direction, and then using the phase shifts, we can steer the beam to a very specific direction. Thank you.